Okay, in this hour, we will show you how exactly the message is exchanged between your operating system, which operate the DNS client, and the DNS server. What is the message exchange between them? Okay, DNS is built on the top of UDP because the DNS, as you can see, that DNS server is very busy. So the DNS server does not have time or any effort to deal with the TCP connection. So they simply just transmit a very small packet which containing the information of top level domain server, root server, and authoritative name server. Okay, so that very simple and small packet. Okay, run on the type of UDP port number 53. Okay, and those records in the DNS server, they are called RR resource record. Okay, but sometimes we will say it's RR or R record. Okay, so basically R record has different fields, but mainly they have 4 different values, which is name, value, and type, and TTL. The first type of the R record is what we call A record. Okay, so for example, right here, A record may look like this. Okay, for example, abc.com. Okay, this record, its name is its host name, and its value might be 4.6.7.8, and because this name and its value, they are host name, the corresponding host name and IP address. So the type right here is A. A stands for it's a record. It's a mapping between host name and IP address. And here we have a TTL right here. Different system may set different values. For example, 3,600. That means 300 second. So that means this record will still valid within 3,600 seconds. So that is one of the record we call A record. Okay, the other type is NS record. So basically it looks like this. Okay, full, for example, abc.com. That means that is a domain name I would like to query, right? But the value right here is the authoritative name server for this specific domain. For example, that means if you want to know the exact IP address of abc.com, you should first go to DNSabc.com. It is an authoritative name server, so it's write NS right here. So you have to ask DNS.abc.com first, because he or it, okay, it knows what exactly the IP of abc.com is. So that is the second record called NS record. Okay, and here we have the third one. Okay, for example, right here, abc.com, def.com, cname. This specific record, a message exchange in the DNS message, that means abc.com is the alias name of, sorry, it should be reversed. def.com is the alias name of abc.com. So if you want to know the exact IP address of abc.com, you should first know what is the IP address of def.com, because they are alias. So we call it a canonical name, CNAME. The reason why we use a canonical name or an alias name is because here is an example. It says the actual www.ibm.com, its actual name is serverist.ibm.com. backup2.ibm.com, because the address sometimes, okay, for example, as we mentioned before, maybe we have CDN architecture. For example, www.google.com. This specific name will never be one single server, will never be one single IP, because there will be tons of users try to retrieve www.google.com. So it would be better to have such kind of canonical name. So www.google.com, it is also named as, for example, in this example, abcc.com is also named df.com, and also named maybe another entry called ghi.com. Okay, so you can see that one single name can have multiple alias name. Okay, multiple alias name, and you can set up different A records. So maybe after that, okay, maybe after that, you can find another A record in the database that df.com is exactly 1.2.3.4, and that's A record. So in this case, we know abc.com is df.com, and df.com is IP address is 1.2.3.4. So abc.com can be retrieved by 1.2.3.4, something like that. Okay, and number 4, this is a very strange setting. It's called MX. So the message looks like this. Okay, think about these two different two record. Okay, as we mentioned before, you take a look at 4-2. It is a record, right? So it means if you want to find nccu.edu.tw, you simply just go to 1.2.3.6, right? So when you enter nccu.edu.tw in your browser, and before your browser try to create the socket, your operating system will try to get this A record. So it knows the socket to connect it to should be 1.2.3.6. However, sometimes there is another record. It has exactly the same host name, nccu.edu.tw, but the type right here is MX. That means this specific IP address 1.2.3.5, it is an email SMTP server. So when you want to send an email, you should find the record, the R record with MX type, not A type. Okay, that is the difference between A record and MX record. That's it. Okay, let's take a look at the DNS protocol message. The request, the query and the reply message, they both have the same format. So they look like this one. The range, it is 4 bytes wide, right? The width is 4 bytes, but there is no any white space or any /r/n right here. Okay, so the very first 2 bytes, 16 bits, it is an identification number. Okay, the second 16 bit is a flag. Its flag will demonstrate it is a query or it is a reply. Does the server, the server you query support recursive query, or if the client desire request query? As we mentioned before, we have eternal iterated query method and recursive query method. Okay, and it will specify if the reply is responsive by the authoritative name server. Okay, so the first 2 bytes are ID, identification, and there are some flags specify what is the situation of current query or response. And here we have 4 different numbers. It specifies how many questions are included in this message, how many answers included, how many authoritative answers included, and how many additional answers included. And all those numbers will be used right here. Okay, so that is so. Let's take a before we. Okay, that's it. Okay, before we continue, I would like to show you some important tools right here. So please take a look at the let's go to the our class website. Okay, and you can see that we do have some material at the right hand side right here, lab. Okay, and you can see number 3, Wireshark. Okay, Wireshark is a tool that can help you to observe it's right here. You can simply just download the tool from the Wireshark's website. Okay, so of course it has Windows version, and the Mac OS depends on you use ARM chip or Intel chip, and some Linux version right here. So you simply just download this one and click install, and then that'll be okay. So let's take a look at my computer. Okay, I believe you can see that. Okay, after you install the Wireshark, okay, please take a after you open it, it looks like this. Okay, and you can see that there is a list right here. There's a list right here. Okay, and it's specified how many different internet how many different network interface cards are there in your PC or laptop or your cell phone. Okay, if you use Wi-Fi, you can simply find this specific interface, Wi-Fi EN0. Okay, if you can see there's some lines right here, that means there are some packet has been transmitted through this specific network interface card. So basically, I believe you can simply just select this one, or you can go to capture options, and you can simply just select Wi-Fi right here. Okay, and you simply click start. And as you can see that, for example, right here, for example, http abc.com. okay, and I press enter right here. So that is the first page of abc.com. Theoretically, your Wireshark can capture, or you can press stop right now. Okay, theoretically, your Wireshark will capture all the packet sent from your host and to your host. Okay, so let's take a look at the HTTP parts. Okay, you can simply type HTTP in right here. That is a filter, so you can filter the HTTP packet. And as we can see that when I press capture, there will be the first, second packet, third packet. So there will be total 4,495 packet has been captured by the Wireshark tool. Okay, so let's simply just type HTTP right here and press enter. Okay. Unfortunately, there will be no HTTP right here. So let's try again. Okay. Capture option Wi-Fi start. Continue. Okay. Let's try HTTP def.com, for example. That is a website that I have never go to. So simply just click this value. Okay. So that is the website. Okay. So let's go back to here. As you can see that there are some messages right here. So you simply just click stop. Okay. And you can see that there are two HTTP packet has been captured right here. Okay. So the first, you can simply just click HTTP protocol right here. So you can see the result. The result looks not that good, but it's okay. You can see that that is get /mfe blah 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 blah, right? The host is to here and it's accept anything. The user agent is right here. Accept language, encoding. The connection is keep alive. That means use persistent HTTP, right? And you can see that the response message is right here. And it says, okay, that is the response message, HTTP/1.1 200 OK from that server. And the content length is 503 bytes. It was last modified this time. So as we mentioned before, if you use if modified header, then that the server will check the date with this last modified date. Okay. So the data is right here. The use persistent HTTP, and here is the 503 bytes, which is right here. You can see at the right hand side there will be a blue part. The total bytes at the body will be 503 bytes, something like that. Okay, and also you can type DNS. Okay, it will filter all the DNS result right here. Okay, so for example, let's take a look at this one, because we at the first beginning we try to know what exactly the IP address of def.com, right? def.com. So right here, and you can see that I think you have to compare it with the slide right here. Okay, so you can see that the first 2 bytes are identification, right? So you can see that the first 2 bytes right here is CB77. These are 2 bytes. That is just simply a random identification number. It's a random number. Okay, so you can open the flags right here. It's also 2 bytes. Okay, take a look at your slide. It is 2 bytes. Okay, so the first bit, if it is 0, it means this message is a query. And there are some other bits which indicate if recursion is desired or something like that. Okay, and in this specific DNS query message, it has only 1 question. Okay, only 1 question. Take a look at this one. So the number of questions right here is 1. No answers, no authoritative R records, no additional records. Okay, so in the following, there are only 1 question attached right here. Okay, so let's take a look at this one. There's only 1 question, no answer, no authoritative R records, no additional record, only 1 query is attached. And right here it says, I would like to query def.com, right? And I would like to know the answer. So the answer is type A, but I don't know the answer. So that is a query. So here you can see that Wireshark says the response is at packet number 357. So you simply just click it, it goes to packet 357. And here, and we can see that the transaction ID is exactly the same as the query packet, right? So the transaction ID is still CB77. And now it is a response. So the first bit in the flag is 1, not 0. 0 is a query, 1 is the response. And it says, okay, do you need a recursion query? Is recursion query available? Something like that, okay? And you can see that it will repeat. It says that we have only one question, but I have 2 answers, 2 R records, which is found by the which is replied by the DNS servers. So we can see that the queries is still the same, df.com type A, but the answers, you can click this one. We can see there are 2 different answers, and it says, okay, I have a type A record, df.com. Its address is 104.21.9.147, or a record 172.67.160.47. So it is possible that you get multiple answer A records from the servers. That is, I think that is because the df.com, it would like to serve more customer, so it set up 2 replica server. And by doing so, when your operating system receives such kind of DNS response, your operating system will randomly pick one of the A records and create a TCP socket to one of the IP address listed here. So in this case, by using DNS server, we can do load balancing, because at least half of the traffic will go to 104 and half of the traffic will go to 172. As long as these 2 servers, they have replica data, so they can serve the customers by using 2 servers. But of the servers, of the clients, they simply just input def.com in their browser. They don't know which IP. Usually they don't know what exactly IP address is used in this socket. Okay, it is a very interesting tool, so that you can monitor the messages exchanged between you and your server. Okay, I saw a very interesting things right here, so maybe we can take a look at this one. Okay, I saw a CNAME right here. Maybe we can take a look at this one. See if we can find some interesting data right here. I saw a CNAME right here. Okay, so of course, because my computer has a lot of different processes is running, so they will continuously send lots of different DNS query, because most of the time we use the domain name rather than use IP, so it has to check out the IP address. So here we can see that the request, okay, so the transaction ID now is CE22. It has one specific question. Its question is, okay, I don't know what exactly it is, but my one of my process want to contact securedcr.imrworldwide.com. Okay, actually I don't know which process initiates such kind of DNS query, but it really doesn't matter. Okay, so we can see that the answer is at 344. So we simply just click it. It says, okay, the transaction ID is still CE22, right? But it has 12 R record. So let's take a look at it. Okay, and you can see that, okay, although I would like to check secure DCR imrworldwide.com, but it says actually it has a CNAME its CNAME is secureus@imworld.com. So I think that is the DCR. I'm not sure what DCR stands for, but I know US, maybe it stands for United States. And it further says that the secure United States.imrworldwide.com, it has another CNAME. It is secure origin imrworldwide.com. And then again, original domain has another CNAME. It is secure AP Southeast-1 blah blah blah. And then we can see that again another CNAME, that is census AP Southeast-1 blah 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 blah. Okay, as you can see that I think the first three is simply just alias name, but the last one is very interesting. That you can see that the domain name is from changes from imrworldwide.com to another domain, which is nelsoncollections.com. That means maybe this nelsoncollection.com, it has certain server. Okay, it serves. Maybe it is a CDN server or it is ISP server. It serves the secure AP Southeast-1 imrworldwide.com. And actually, it has several different array records. As we mentioned before, for the load balancing purpose, you can set up several different IPs. But they use the same names in the array record. But after my process receives such kind of DNS reply, my operating system will randomly select one of the IP address right here and use this one of the IP address as the original secure-dcr.blah.com and create a socket and try to connect it back to try to connect my process and the remote secure DCR imrworldwide.com. Okay, so you can see that it's very interesting things right here. Okay, I think that is another interesting one. You can see that is a response, and the question is right here. I would like to find a domain which is r3.o.lencr.org, but actually this one has a canonical name, and you can see that it's very interesting. This specific domain will have an other CNAME which is operated by akamai.net. As I mentioned before, Akamai is a very important CDN company, so it helps a lot of different servers to do replication, to replica their server in different location. For example, in Taiwan, in Japan, in different countries, they have built a lot of different local servers to serve local users. But when you type r3.o.lencr.org, but actually it will goes to a server which is operated by the Akamai, and Akamai has two servers, which one is 203.214.242, and the other one is 170.137. Okay, so in this case, Akamai can help different service providers, service provider to build their own machines among different countries, because Akamai has different has already built different hosts in different countries. So by using DNS, they can easily to do content deliver network. Okay, I would like to show you some other things about HTTP. So let's simply just capture more packet. Okay, and we go here, and maybe we can let's try abc.com. okay, abc.com. Press enter, and then here I think is it possible that we can, fortunately, as you can see that although I've typed abc.com right here, but the packet does not show any packet related to abc.com, right? That is because I have already typed abc.com before, so my browser cache all these pages. Okay, cache all these pages. So there's no actual packet transmitted through this Wi-Fi card. So let's try nccu.edu.tw. okay, so again, no, maybe that is because I've already retrieved nccu.edu.tw before. Okay, so okay, that's fine. So maybe we stop right here. Let's still take a look at DNS. We can see where is the it's right here. Do you see that? That is the DNS record of nccu.edu.tw. So you can see that the response is right here, and you can see the A record is right here, 140.119.168.10. That is the IP address of www.nccu.edu.com. Okay, so I think that is good enough. I would like to show you a very interesting HTTP packet and see if I can find it. Okay, so let's see if I can capture. Those are not good. I think that is because I've already used the things. And the other things is right here, because you can see that Microsoft.com actually its protocol is HTTPS, not HTTP. So we cannot see any. As you can see that if you use HTTP as the filter, as you can see that if you use HTTPS, or the actual name is SSL, and you can see that there's an encrypted HTTP data right here, but because it is encrypted, so we cannot see the actual packet in the layer 7 protocol. So let's try again, see if we can find what I would like to show you. I don't know what exactly. because all those website currently they have a lock right here. So basically they are HTTPS, they are not HTTP. So you cannot capture all those HTTP messages in your Wireshark. But okay, I think that's okay. We can stop right here. So make sure you know we do have homework today. So take some time to take a look at the homework which is announced today. We have homework 02. Basically, it's you have to install Wireshark in your computer and try to capture some information and try to answer the questions I asked in the homework. Okay, so try to. So if you have any question, you still have time. You can ask TA by email. You can go to forum to ask questions. You can send me an email or ask me next time when we meet in the classroom. Okay, we still have time. You have 1 week to write homework number 2. Okay, I think we stop right here. It is that is our schedule. We stop right here. Okay. So don't forget your homework.